in part 2b, we shall look at the adiabatic invariants of the ideal gas. Namely, if we make a process in which delta S is equal to 0. Okay. Suppose you go from 1 to 2, in which delta S is equal to 0, in which the system keeps its entropy constant. So if the parameters of the system are TV or TP or PV, how do they change? Let me start. So let me call this 1, 2, 3. Let me start from 3 because it's the famous thing. Okay. So this is a constant. So when you make delta S2 minus delta S1 to 2 is simply, since this is a state function, S2 minus S1. So for 2 you write N is the same. We are looking at the same gas. It's the same CV, CP. So it is P2, V2 and P1, V1. As you see, this will drop out. But the variable, when you make the change, what is changing is P and V. So it is easier even to look at the SPV constant if, because N is constant, if this is log P to the CV times V to the CP is constant. Since N is constant, I don't care about it. So the log of it or itself must be constant. So P CV V CP is equal to constant. It is usually written this way. Take the root 1 over CV. So P times V to the gamma is equal to constant, with gamma is equal to CP over CV. So PV gamma is equal to a constant. Constant gamma is equal to CP over CV. So if you make an adiabatic process with an ideal gas, P times V to the gamma remains constant. P and V changes, but this combination remains constant. All right. What else? Let's look at 1. This was from 3. So it says log T to the CV times V to the R is equal to a constant. If log is constant, function itself is a constant. Or if I can write it like this, T V R over CV is equal to a constant. And what is R? CP minus CV is equal to R. So instead of R, I can put that thing in. So it is T V CP minus CV over CV, which I will write as T V. CP over CV is gamma minus 1. That's equal to a constant. So 1 gives T V gamma minus 1 is equal to a constant. Now, how about the second one? Well, from the equation of from here we can take it out. PV gamma is PV gamma equals constant gives me that V causes P minus 1 over gamma. Because you divide constant by P, then take the gamma root, P to the minus 1. You take the gamma root, P minus 1. So it is T, instead of V, I put that P minus 1 over gamma raised to the power gamma minus 1. Gamma minus 1 is equal to a constant. So, finished. T P minus gamma minus 1 over gamma is equal to a constant. So, all right. Now, a bit more involved problem. Suppose in a gas, in a volume V, I have two gases, 1 and 2. So it has N1, N2, CV1, CV2, and CP1, CP2. These are the molar specific heats for constant volume and constant pressure, and they may be different. One may be a monatomic gas, the other one is polyatomic gas. But they will not react. They are just gases. So suppose in this system, you are considering a process in which the total entropy does not change. Delta S equals 0, total. What about the adiabatics of this system? If there was only gas 1, everything here would carry the index 1. Gamma, so the CP1 over CV1, it would have been gamma 1. Or if it were only gas 2, gamma would be gamma 2, CP2 over CV2. But what if we have two such gases mixed? Okay, then we have to look at the total entropy. So let's write this. All right, let me just take this one. S PV total, that's equal to S1 plus S2. Let's write it. N1 CV1 log. So this system has temperature T and pressure P, but pressure P is due to the pressure of the gas 1 and also of the gas 2. So we have to take that into account. CV1 log P1, not P but P1, plus NCP1 log V over N1, V is the same, plus N1 S01 PV. So entropy constant of the first gas, plus, we write the same thing for the second one, N2 CV2 log P2 plus NCP2 log V over N2 plus N2 S02 PV. So we are trying to find out what happens if the total entropy does not change, as total is equal to 0. So what are these partial pressures? P1V is equal to N1 RT. P2V is equal to N2 RT. So if we add them, PV is equal to N1 plus N2 RT. Therefore, P1 is equal to N1 over N1 plus N2 P, and P2 is N2 over N1 plus N2 P. Since n's are, we are taking the logarithm, so it's the logarithm of that plus the logarithm of that. Since this is constant, we don't care, so we only look at P. So we have log P N1 CV1. From here, N plus N2 CV2. And from here, we have V N CP1, N1 CP1 plus N2 CP2, N1, N2 CP2. Basically, we are done because if the log, see, delta S will not change, so this has to be constant. If the log is constant, the function itself is constant. I take the root to that power, so it is P V N1 CP1 plus N2 CP2 over N1 CV1 plus N2 CV2. This is equal to constant. Let me erase. This can be written in a more... let me erase this one. So we just did this, we simply wrote this for two gases. We simply copied and added. But for example, the average of CP, we can define N1 CP1 plus N2 CP2 over N1 plus N2. And likewise, we define CV. So we see that the adiabatic invariant is PV gamma tilde is equal to a constant, where gamma tilde is average of CP divided by CV. So two gases, so this is one gas, two gases, 1 and 2. PV gamma tilde is equal to a constant. Gamma tilde is not CP over CV because we have two gases. It is CP average divided by CV average. Let's look at another thing fast. Whether this also works out. Is it the same way? So T N1, I'm just reading from here now. N1 CV1 plus N2 CV2 times V N1 R plus N2 R. Therefore, I can write this thing as, since the gases are ideal, I can write this power as V N1 CP1 minus CV1 plus N2 CP2 minus CV2. Because for any ideal gas, Cp is equal to Cv plus R for any gas. If it's monoatomic or diatomic or polyatomic, Cv changes, but this relation holds. So we take this root. What do we get? We get T V gamma tilde minus 1 is equal to a constant. So, like this one again, T V gamma tilde minus 1 is equal to a constant. Now it's very easy to get the last one because V goes as P minus 1 over gamma tilde. So if you just put it in here, T P minus gamma tilde minus 1 over gamma tilde. So with two gases, this one, T P minus gamma tilde minus 1 over gamma tilde is equal to constant. We did it for two gases, but it's clear now that you could have k different gases. Okay, so I'm erasing this part. K different gases, different ideal gas. So Nk, Cvk, Cpk, and again we will define gamma tilde as Cp average over Cv average. So all these formulas are the same. So it's not really specific to two different gases. To k non-interacting different gases we can generalize.